This is a UTME physics problem, and the question says that we have a light uniform meter rule MN pivoted at O, which is the 80 centimeters mark. A load of mass 3 kilograms is suspended on the meter rule at L, as we can see here, which is the 10 centimeter mark. So we can put a 10 somewhere around here. So the meaning of all this mark is that from this M can be regarded as the 0 centimeter mark. So as we're going forward, L is 10 centimeters, R is 20 centimeter mark, and then this is 80 centimeters mark. So the question we are looking for is the tension T on the string. This is the string P. Yeah, so we are looking for the tension in this string. So the first thing I want us to do here is that I want us to find the corresponding weight to this. Of course, we know that is to multiply this by the gravitational acceleration, which is g, and here we'll be using 10 meters per second squared. So the corresponding weight here is 30 newtons. Now, of course, we are familiar with the principle of moment, which says that the sum of clockwise moment equals sum of the anti-clockwise moment. However, the moment is taken in such a way that we multiply the force times the perpendicular distance away from the pivot. So for this tension now, as we can see this tension is not really going to be acting perpendicularly to the meter rule. So if it's going to be acting perpendicularly to the meter rule MN, then it's supposed to go in something of this nature. Yes, it's supposed to go in something of this nature that is acting perpendicularly to MN, so that we can take the perpendicular distance from here to this pivot. Now, the good thing is that we are given the angle with which the tension subtend with the uniform meter rule. With this angle, we can easily get the component of the tension along the vertical. Now, the angle made with the horizontal is 30 degrees. If an angle is made with the horizontal by a vector and you want to find the vertical component of such vector, all you have to do is to multiply the magnitude of the vector, which will be t in this case, multiply it by sine of this angle. That is the rule. If the angle is made with the horizontal and you want to find the vertical component of that vector, tension is a vector, all you have to do is to multiply the magnitude of this with the sine of this angle. So this particular component right here that I just got now is going to be, so let me create more room so that I can write what that is. So that component is going to be t sine 30 degrees. So what I'm going to do is that I'm going to ignore this particular one now because I need the vertical component. The next thing I'm going to do is that I'm going to inspect how many forces are acting here, how many forces are acting here. And then because they've already said that this is a light uniform meter rule, this is telling us to ignore the actual weight of the meter rule. So we don't need to bother about that. Now there are two forces acting here. This 30 newtons acting downward, and there's this t sine 30 degrees acting upward. There's no other thing. Of course, in this pivot, which I will talk about later in another video, there's always a force acting upward here, but we don't need that here since we are taking our moment about this pivot. So if I pin this down, so you can assume that you are holding this down. If you're holding this down with, let's say, your finger, and then you try to go in the direction of this force, which is what? Upward. How will this thing rotate? Of course, it will rotate in this manner. And this manner of rotation is a clockwise rotation. Let me repeat that again. Hold this pivot down and act in the direction of this force. Of course, we know that moment is the turning effect of a force. So how will this meter rule, how will it turn? It will turn with this arrow that I've just signified here, which is a clockwise moment. So which means that this is going in the clockwise. So for the clockwise, we have t sine 30 degrees. Of course, what will be the perpendicular distance? We know that this place to this place is 10, and this place to this place is 20, this place is 80. So from the 20 centimeters mark to the 80 centimeter mark, that will give us a difference of 60 centimeters. So that will be multiplied by 60. I don't need to bother about the centimeters converting it to meter because we are comparing two things here, and then the centimeter thing would actually cancel out. So I don't need to worry about it. Now, let's continue with the second one. The second one is acting downward, which is 30 newtons. The same thing again, fix your finger. So when you're using your book to do this kind of thing, you can fix your finger on this pivot that you're taking the moment about, and then try to act in the direction of the force. Which way will it turn? Of course, we know that this one will turn in this direction. Will turn in this direction. And this direction is going to be the anti-clockwise direction. So we have the anti-clockwise, and that will be 30 multiplied by. Now, what will be the perpendicular distance? From 10, this time around now, from 10 to 80 centimeters mark. That will be 70. That will be 70 centimeters. So now, since we have done with all the two forces that are acting in this system, then we can use the principle that sum of clockwise moment equals sum of anti-clockwise moment. The implication of this is that we would have t sine 30 degrees multiplied by 60 equals 30 multiplied by 70. Now, let's do some calculation there. So this implies that t multiplied by 60 sine 30 degrees. Now, if you press this on your calculator, sine 30 degrees will give us 0.5. So 0.5 times 60, that will give us 30. So this is t times 30 equals 30 times 70. Then this 30 can cancel out. And then at the end of the day, you know that t equals 70 newtons. So that implies that the tension in the string, the tension on the string is 70 newtons. If you would like to see more videos like this, solving UTME problems, please subscribe and follow. I'll see you in the next one.